Hello everybody. This is your extra practice problems walkthrough video for right triangle altitude theorem. So let's go ahead and jump into it here. This one's going to be fairly short. I don't have too many problems for you here because I did a lot of examples for you and a lot of explaining in the actual notes video. Okay. All right, but let's take a look at this. So I have this lovely figure right here, which is the side view of a garage, right? And then I have part of the roof that hangs over the garage, right? And it wants me to find each of these things, right? So they want me to find X, Y, and Z, right? And I know that the height of this triangle, the altitude is 6, and the part that hangs over is 2. Right? So if I'm going to find X, whoops, hold on. Sorry, guys, I'm getting lots of notifications. So if I'm finding X here, right, if you think back to the notes video, I had a lot of different strategies that you could use. For this one, I think I'm going to use the Pythagorean theorem, right? And here's why. If you kind of forget all of this extra stuff and just focus in on this small triangle, you have A, B for A squared, B squared, right? And what you're looking for is C, right? So let's see if we can figure out what that is. So I have 2 squared plus 6 squared equals X squared. So this is 4 plus 36 equals X squared. So you end up with 40 equals X squared, right? And then remember, the rule is whenever you have an exponent that you're trying to get rid of in an equation like this, you have to take the square root of both sides. So square root, square root. So what you end up with is X equals, and I'm going to round here because I plugged this into my calculator, so X equals 6.32. So that's part A. Part B wants to find the value of Z. So not just this part right here. They want to know the entire length. Okay, but I already know this part is 2, the smaller part. So if I can figure out what the larger part is, to find Z, I can just add those two things together. So for this one, I'm going to use the short over altitude equals altitude over long. Okay, where let me switch my color here, where this 2 is my short part of the hypotenuse, 6 is the altitude, and then the long part of the hypotenuse is this question mark, right? So I'm going to figure out what that is first, and then whatever that is, I'm going to add 2 to it so that way I can get the length of Z, which is this whole thing. Okay, so I have short, which is 2, over altitude, which is 6, equals altitude 6 over long, which is my question mark. Okay, I'm going to do my cross multiplication so that I can solve this. So I end up with 2 times my question mark, or like I said in the previous video, you can use a variable. I just used a question mark. Okay, equals 6 times 6, which is 36. Okay, and my last step in order to get the question mark value by itself is to divide by 2 on both sides. So when I do, I get that my question mark is 18. So that means that Z is equal to 18 plus 2, which is 20. And that is a 2, even if it doesn't really look like it. Okay. All right, then my very last step is to find the value of Y. Now, you can do this lots of different ways, right? Just like in the previous video, once you have most of these side lengths, you can find the last one in lots of different ways. But just to show you guys the third formula, I'm going to use fraction formula number 2, which is, oh, hold on, sorry. Let me scroll up so that you guys can see it, okay, which is this one, hypotenuse over leg equals leg over adjacent segment, because what I'm looking for here is Y, which is the leg. Okay, so Y here is my leg, my hypotenuse is Z, Okay, and the adjacent segment is my question mark value. Okay, so it's hypotenuse, which is 20, over leg, which is y, that's what I don't know, equals leg, y, divided by the adjacent segment, which was 18. Okay, so I'm going to do my cross multiplication here. So I end up with y times y is y squared equals 20 times 18 is 360. And now my last step is I need to take the square root on both sides. And when I do that, you will likely have to round. So I got, when I plugged that into my calculator, y equals 18.97. Okay, so that's it for this problem. All right. So give me just a second. Let me clear my screen, scroll down to the next problem. I'll see you in just a second. All right, y'all. So here's the next problem, which kind of goes back to what we learned about kites and about quadrilaterals. It's been a hot minute since we've talked about those, right? But this is one of those ways that this right triangle altitude theorem can help us, right? Rather than having to use properties of kites, which there's a lot of them and they're kind of hard to remember if you just know this one formula, right? Because you have these right triangles in a lot of these kites. So let's take a look at this one. Okay, so I have these two measures of the long diagonal, 6 and 24, and they want to know the length of the short diagonal, which is this entire thing right here. That's the end goal. That's what we're looking for. Okay, but what's cool about kites, if you remember, is that they are symmetric about or across one of the diagonals, which is the one that we know the length of. So if I can figure out what this part of the diagonal is at the top, it's exactly the same at the bottom. So whatever answer I get, I'll just double it because there's two of them, right? And so if I kind of ignore the right triangle at the bottom, this right triangle at the top looks very similar to what we've been working with, where x is the altitude, 6 is the short part of the hypotenuse, and 24 is the long part of the hypotenuse. So let's set up our equation. So 6 over x equals x over 24. Again, I'm going to do my cross multiplication. Okay, so I end up with x squared equals 144. And then I'm going to take the square root of both of those, so I get that x is equal to 12. That's not what I'm looking for, right? Remember, the goal was to find the length of the whole short diagonal. So the diagonal is 2 times 12, which is 24. And then I want to go back and make sure that I include my units because the problem has units, right? So if they give you units in the problem, you really should give units in your answer. All right. So last one, I'm actually going to let you all try on your own and then check back with me to see if you got it right. Okay. So I have a couple of right triangles, right, where I have my altitude drawn through. It just looks a little bit different because it's kind of flipped on its side, right? So we have this girl, she's 5.5 feet tall, and she's standing 12 feet away from the tree. And we're going to use that to figure out how tall the tree is. Okay, so the first thing that it wants you to do is write a similarity statement. So remember, that's when you write, where you have triangle blank is similar to triangle blank is similar to triangle blank, where these are the small, medium, and large triangles. So remember, whatever order you write the first triangle in. So like whatever path you follow, whether you go along the hypotenuse first, or if you go along the shorter side first, right? Whatever you decide, right? Make sure you write the other two triangles in the same order. You follow the same pattern, right? And then again, we're trying to find how tall the tree is. Before I can do that, I need to figure out what XW is, right? And then do something very similar to what we did in question number 1. when we were trying to find z. Okay, so I want you to give this one a try on your own, pause the video, and then check back with me in just a second to see how you did. All right, folks, so go ahead and check your answer against mine. So for part A, yours may look a little bit different than mine. You may have followed a different pattern than I did, right? But as long as your vertices match up how they're supposed to, then you're fine. So the path that I followed to name the triangles is I started and went along the shortest side, right? So for example, in this small triangle at the bottom, I went along the shortest side, YW, and then up the longer leg, right? So I went short leg, long leg, right? So YWZ was my first one. For my medium triangle, it would be ZWX, right? Because I'm going from along the shortest side of the triangle to the right angle and then going up the other leg, right? And then for the big triangle, it was YZX, okay? And then for finding out how tall the tree is, I set up one of my fraction formulas. You're probably coming to notice that the first fraction formula that deals with the altitude comes up a lot more often than the second one, okay? So I have my short divided by altitude equals altitude divided by long. So my short segment of the hypotenuse is 5.5, my altitude is 12, and my long segment is xw. So I did the cross multiplication, divided by 5.5 on both sides, and got xw is 26.18. But then I had to go back to the question and say, okay, that's not what the question is asking me for. They want to know how tall the tree is, right? So I had to add the 5.5 feet back in to get the full height of the tree. So that's what I did here on the right-hand side. And I ended up with 31.68 feet. All right, folks, that is it for this video. I'll see you in the next one to talk about Pythagorean theorem. Bye, everybody.